The learning objectives for this topic are: solve logarithmic equations using the one-to-one property, solve exponential equations, solve exponential equations in quadratic form, and solving logarithmic equations. Let's begin by looking at the one-to-one property of logarithmic functions. On the left here we have a definition. One-to-one property of logarithms is: for b greater than 0 and b not equal to 1, the log of b of x equals the log of b of y if and only if x equals y. But what does this one-to-one property really say? That says this: as long as functions have the same base, being the b at the bottom of the equation here, that is, that they have the same graph, wherever that function exists, for every value of x there is a unique value of y. And the opposite is also true. For every value of y, there's a unique value of x. So you can perform the same operation on both of these sides of the equation and use that to transform it into something that's easier to solve. So what does all of that mean? Let me explain. The one-to-one property of logarithmic functions can be used to solve exponential equations. So if I have an equation e to the x equals 3, the application of the one-to-one property is called taking the log of each side of the equation. This can be done with any base, including the natural base number, e, or Euler's constant. So, using the one-to-one property, the log of e of x equals the log of 3. That's taking the log of each side of the equation. The log of e of x is just x, and the log of 3 can't be simplified. However, you can, on your calculator, just by typing in ln3 and the equal sign, find an approximate answer, and the answer in this case is 1.0986. You can try that for yourself. Let's take a look at a slightly more complex example. Here we have the equation log 4x equals log 4(3) plus log 4 of x minus 2. As you can see, all of the terms in this equation are log 2 base 4, which means we can apply that one-to-one property. So take the original equation. Remember that for this topic you will need to know the basic properties of logs. If I add two logs together, then what I am doing is actually multiplying those two factors inside the logs. So this side of the equation becomes log 4 of 3 times x minus 2. You can expand that, and then we take the log of both sides of the equation. So in this case, log 4 equals x and 3x minus 6. Simplifying that equation, we get the answer x equals 3. Now it's time to have some practice. We have two equations here that need to be solved. Equation A is with log base 6, and in equation B, the terms are log base 12. See if you can solve these using the method described in the previous slide. Pause the video now and we will come back and take a look in a few minutes. Okay, for equation 1, we have log base 6 on both sides of the equation here and here. So we can just apply the one-to-one property straight away and make the 2x equal to this expression inside the brackets here. Simplify by taking the terms to the other side of the equal sign, factorize, and you'll come up with the two answers, x equals 1 and x equals 2. For the second equation, takes a little bit longer, but we have, again, both of the expressions here are in log base 12, base 12, base 12. Remember, when we're adding two logs together, then we multiply the two terms inside the log. So in this case, you'll just get x plus 3 equals 4x. Rearranging that equation, 4x minus an x equals 3x equals 3. And your final answer should have been x equals 1. As well as solving log equations, we can also use this method to solve exponential equations, like the one in this example. Here we have e to the power of 4 minus 3x equals 6. We can take the natural logarithm of each side, so the log of e to the 4 minus 3, 6 equals the log of 6. And in this case, we're just going to get 4 minus 3x on this side for taking the log of e, and log x remains on the other side. You can simplify this function by rearranging the terms to get x equals log 6 minus 4 divided by a minus 3. And again, this does not have an exact value, but you can use your calculator to find out the final answer, which is about 0.74. Now let's look at 3 examples for practice. We have 3 equations here, 8 to the power of y, 1.43 to the power of a, and e to the power of 2 plus 5w. Just a hint before you attempt these questions, you will see that these first 2 equations, a and b, do not have the letter e, the variable e there for natural logarithms, so these 2 will have to be solved using the log to base 10. Okay, stop the video now and we will take a look at your answers in a few minutes. Okay, for the first example that we have here, we can take the log of both sides. Remember, log of base 10, log, of 8 to the power of y, but you might remember those log laws, that if you have something to the power of y, then that actually comes out the front of the expression here. So y times log 8 equals log of 0.165. Rearranging that equation, you just divide this side by log of 8, and if you put that into your calculator, you'll get an answer of minus 0.866. For the second example here, similar kind of thing, we have log of 1.43. The a, power of a, comes out the front of that expression. You have log of 3.1 and log of 8.48. Rearranging that equation, you will be left with a equals log of 8.48 minus the log of 3.1 divided by the log of 1.43. Putting those numbers into your calculator, you should get an answer of 4.70 approximately. For the third example, so this is where you can use natural logs, so ln e to the power of 2 plus 5w. This time it will just, the log of e will just bring that expression down the bottom. And the other side is just the log of 12. Rearranging that equation, you will get log 12 minus 2 divided by 5. And if you put that in your calculator, you'll get an approximate answer of 0.097.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
This particular property can be applied in a number of different areas, and this is one that you might not expect. It's called, or uses the quadratic form. So if you have an exponential equation that is in quadratic form, you can simplify that by using a substitution. So e to the power of 2x and at e to the power of x, you can substitute u equals e to the power of x into those equations to turn that into a quadratic equation. U squared plus 6u minus 16 equals 0. How do we find the solutions? Then we can factor that quadratic equation. In this case, you have the answer for two factors, u plus 8, u minus 2 equals 0, and equate those coefficients there. Will give you an answer of u equals minus 8 and u equals 2. Now you might think that's the final answer, but don't forget that we have substituted into this equation to begin with the value of u equals e to the power of x, so we need to substitute that value back in to find a solution in terms of logs. So here we have e to the power of x equals minus 8. Take the log of both sides. In this case, you'll get x equals the log of minus 8 for one answer, and x equals the log of 2 for the second answer, which you can work out on your calculator to be approximately 0.69. Now, we have two solutions, or two potential solutions to this quadratic, but remember, when you're taking a log of a negative number, it's important to check whether this answer is valid or not. In this case, the log of minus 8, you can check on your calculator, you will get a calculation error, so it's good to do that, but you should know that taking the log of a negative number in general is not going to give you a solution. Now that we've seen that example, let's take a look at two equations here. The first one, e to the power of 2x plus 2e to the 2x equals 8, which is very similar to the example that we've just done. And example B, 4e to the 4x and 8e to the 2x, is slightly more complicated, a bit more of an advanced problem. Stop the video now and see if you can work out the solution to both of those problems, and we will come back and have a look at the answers in a second. Okay, for the first equation here, we have e to the 2x plus 2e to the x equals 8. So exactly like the example, we're just going to substitute in u equals e to the power of x into that equation, which will give us a nice quadratic equation to solve. U squared plus 2u minus 8. You can factorize that by any method you choose, but it should be fairly easy to just guess and check that one. You have u plus 4, u minus 2 equals 0. So the two different values of u, in this case, u equals minus 4 and u equals 2. Again, this isn't the final answer. Don't forget that you have to convert it back into an exponential equation with this same u equals e to the power of x that we find up here. So e to the power x equals 2 takes the natural log of both sides, and you'll end up with the answer x equals the log of 2. What happened to the other answer, u equals minus 4? Well, as we've seen in the previous example, this is going to be an extraneous solution because taking the log of minus 4 will not give you an answer. As I suggested before, the answer to the second equation here is a little bit more complicated, and you might have even guessed for yourself that if you saw a 4x in the power of the top and the 2x, that you would use e to the power of 2x instead as the substitution. But you can even take it further than that by making the u equal to 2 times e to the power of 2x, which will also simplify the numbers out the front. Yep, because the 2 squared is going to become 4 there, and it will simplify the equation. Okay, we have u squared plus 4u minus 5 equals 0. Factorize that equation. U plus 5, u minus 1. Again, you're going to get 2 solutions. This u minus 5 is going to be an extraneous solution, and the one that you are really looking for is u equals 1. Remember to substitute back in that whole expression for u. So for u equals 1, 2 times e to the power of 2x equals 1. We can divide both sides by 2, which will give you e to the power of 2x equals a half. Then you can take the log of both sides. So log of this equals 2x, log of 0.5, and then again divide both sides by 2. You'll get the log of 0.5 divided by 2. Final answer on your calculator, x equals minus 0.346. And hopefully you got at least as far as this answer, but if you completed that whole solution there, then you've done very well. The last thing we're going to take a look at in this lesson is solving logarithmic equations. So in this case, you start out with a log equation, log of x plus 2 plus log of 3x minus 2 equals 2 times log of 2x, similar to the examples that we did earlier. Okay, so you've got the basic log laws coming into effect again here. These are a little bit more complicated than the examples before, but they work the same way. If I'm adding 2 logs together, then I'm multiplying those 2 factors there that are inside the log functions. And same with this side. If I have 2 times the log of 2x, then that's going to be log of 2x to the power of 2. That's opposite to what we did with the exponential equations before. In this case, we can collect those or expand out those 2 brackets to make this expression here, and also expand out or multiply out those brackets to make 4x squared. Then we can equate both sides by removing the log signs. So we've got 3x squared plus 4x minus 4 equals 4x squared by that old one-to-one property we're using once again. Then we can just simplify the equation, factorize it, and in this case you're going to get 2 factors that are the same, x equals 2. Now it's time to practice finding the solutions for log equations, or logarithmic. Okay, so example B is very similar to the one that we did in the example on the previous slide. This example here, there are actually 2 different ways of doing it. If you want a hint, then you can use the log laws, the basic log laws of if you have one expression here and one expression here, then you are subtracting one log from the other, then you divide those 2 expressions. There is another way to do it. Let's see if you can come up with the alternative solution. Okay, so stop the video now and we will come back in a few minutes to have a look at the solutions. Righty, as I was saying, that one way of solving this problem is to subtract or divide log of x plus 1 into 7x plus 3. But another easy way to do it is just move that expression, the minus log expression, over to the other side of the equation, and make it a plus. Yep, there, that way it becomes the same as the example that we've done before. Yep, so log of x plus 1 plus the log of 2x means that you can multiply those two expressions together. You'll get on the left-hand side, using the one-to-one property, you'll get 7x plus 3 equals 2x squared plus 2x when you multiply those two factors out. Now 2x squared minus 5x minus 3 is going to factorize into 2x plus 1 and x minus 3. So you will have one whole number answer, x equals 3, and also one negative answer, minus a half. In the second example here, said if you're adding two logs, then you multiply the two factors inside those logs together. In this case, you're going to expand those out to get a expression that's going to give you a polynomial. So multiply the 2x plus 1 times 2x minus 3, you will get 4x squared minus 4x minus 3. And the 2 outside of the log sign here, again, is going to go up to the power on the top of that expression. So log of 2x minus 2 squared, use the one-to-one property on that particular expression, and again you'll get something that will give you a polynomial, 4x squared minus 8x plus 4. The good news is that both of those terms at the highest terms in those polynomials will cancel each other out. So you're left with a simple equation, 4x equals 7, and the final answer in this case will be x equals 7 divided by 4.